All right, so this is the first video in graphical analysis that we will be going over today. Just a couple of things that I want to go over to remind you are what first derivatives and second derivatives tell us about functions. So first derivatives. First, a couple things you're going to be looking at is if your f prime of x is positive above the x-axis, or if your f prime of x is negative below the x-axis. If your first derivative is positive, that means your original function, f of x, is increasing. And then if your first derivative is negative, f of x is decreasing. Kind of just a little review on part of the first derivative test, I guess. Okay, same goes for second derivatives. If your second derivative is greater than 0, then your first derivative is increasing, and vice versa. If your second derivative is less than 0, then your first derivative is decreasing. Okay, and this idea helps us with concavity, right? So concave up, concave down. Okay, and then trying to think some other things. Oh, if f prime of x is equal to 0, then that means you have some sort of relative extrema because it's a critical point. And then to tell if it's going to be a relative max or min, you just have to look at what's happening on either side. So if your f prime of x at that point where it's 0 changes from, let's say, positive to negative, so changes from your regular function would change from increasing to decreasing, you're going to have a relative max. And then conversely, if f prime of x changes from negative to positive, or in other words, f of x changes from decreasing to increasing, that would indicate a relative minimum. Okay? So that's like your first derivative test. That's how you use your first derivative to get your max or min values. And then this is just your concavity. And wherever you switch concavity, so if your second derivative changes from positive to negative, or your first derivative changes from increasing to decreasing, that's where you're going to have those points of inflection. Okay? All right, so keeping all of this in mind, if you need to write this down, pause here so you get this on a sheet of paper so you can access it as we go forward. Here is a graph that we are given, and we are told that this graph represents f prime of x. So the first question is, on what intervals is f decreasing? And we just talked about that your original function is going to be decreasing wherever your first derivative is less than 0. So on our graph of the first derivative, that's going to be happening wherever it's the graph is below the x-axis, wherever it's in those negative values. So right here. So the interval of decreasing for f is where f prime is negative, so from 9 to 10. And your explanation for that would be because the first derivative is negative or less than 0. Next question, where does f have a relative maximum? Well, your relative maximum would be concave down, look something like this. So it's where your first derivative is going to change from positive to negative. So it looks like here we're changing from a positive f prime to a negative f prime right here at x equals 9. So we're going to say x equals 9 because f prime of x changes from positive to negative. And you might want to actually write out the words. Just for sake of time, I'm doing abbreviations and symbols. All right, concavity. So remember, concavity deals with the second derivative, but we can think of the second derivative in terms of the first derivative. So concave down is where your second derivative is negative or less than 0. If your second derivative is negative, that means your first derivative is decreasing. So we are looking on this graph of f prime of x where it's decreasing. So we have decreasing here, here, and here. So from 0 to 3 and 4 to 6 and then 8 to 10, it looks like. My graph is small. I'm pretty sure that's right, though. And then our explanation with this would be because since f prime of x is decreasing, then f double prime of x is less than 0, so concave down. Okay? Part D, keeping in mind here that this graph represents f prime of x, find the x value of any points of inflection. Now, points of inflection we've mentioned are where the second derivative changes sign. So where the second derivative changes from positive to negative or vice versa. So we'll do a double arrow there. So that's going to be where your first derivative changes. Okay, Mrs. Bannock can't spell today. Changes from increasing to decreasing or vice versa. So I'm going to highlight all of those spots. So here we change from decreasing to increasing at this x value of 3. Then it changes again, increasing to decreasing at x equals 4. Then from decreasing to increasing at x equals 6. And then one more time, increasing to decreasing at x equals 8. So our x values are going to be 3, 4, 6, and 8. And your reason would be because since f prime of x changes from increasing to decreasing and the other way, then f double prime of x, changes sign from positive to negative or vice versa. All right, then part E. On what intervals is f both concave up and increasing? So this is where we're looking second derivative is greater than 0 or first derivative is increasing. And then where f is increasing is going to be where your first derivative is greater than 0. So first let's look where our first derivative is increasing. So here and here. And then it's positive in both of those spots as well. So those are going to be our two intervals where it's concave up and increasing. So from 3 to 4 and from 6 to 8, it looks like. And your reasoning for that would be because f prime of x is greater than 0, and since f prime of x is increasing, then f double prime of x is greater than 0. All right. So if you're still trying to wrap your head around how f prime of x, f double prime of x tells us concavity, increasing, decreasing, points of inflection, all of that, go back to the page where we listed it all out. See if you can try and do these first 5 problems kind of on your own again. Maybe try them on a blank sheet, because part F is a little different. So pause here if you need to, and then come back and you can do part F. So for part F, if we're given that f of 4 equals 2, find f of 8. Okay, so right now we're trying to relate the original function back to the derivative, okay? So to undo a derivative, to be able to get this graph of f prime back to the original f, we have to use integrals. So we're essentially trying to find the integral of this graph using f of 4, f of 8, so using 4 and 8 as our x values. So what we're going to be using is actually our fundamental theorem of calculus. The integral from a to b of a first derivative is going to be the original function evaluated at b minus the original function evaluated at a. Because again, integrals, derivatives are inverses. So we're looking at the integral from 4 to 8, because those are our two x values we're comparing, of f prime of x dx equals f of 8 minus f of 4. Now, hopefully, if you're looking what we're trying to find and what we know, kind of we're already at a point where we'd be able to solve for this f of 8. First thing to remember is, in this situation right here, the integral, remember, is the area under a curve. So this just means we are finding the area underneath f prime of x from 4 to 8. So here we are at 4, here we are at 8. We need to find that area. So nice thing about having just straight line segments, it looks like we can break this up into two sections. So this is one trapezoid. This looks like another trapezoid. The area of our first trapezoid here is base 1 plus base 2 times height divided by 2. So base 1, it looks like, is 5. Base 2 is 1 times 2 divided by 2, because the height is 2. All right, and then our next one, base 1 plus base 2, so 1 plus 2, times the height, which looks like that's also 2 over 2, equals f of 8 minus f of 4, which is 2. So then to keep solving that, if you simplify those areas that we calculated, you would get 6 plus 3, so 9 equals f of 8 minus 2. So then you add 2 to both sides, you get 11 equals f of 8. All right, which brings us to the next example, which is actually in the next video. I just wanted to try and keep it short for you. So what I'd like you to do is just review what you just went through, make sure you understand it. Meet me in the Google Hangout or shoot me a text on Remind if you still have questions about it to clear that up, and then go ahead and go on to the next example because that one's going to look a little different. So pause here, review anything you need to, watch the second video, ask questions as you need to.